Hey everyone, I think we're streaming right now. Yeah, there we are. Good. What we got going on? Can we go over the nonprofit question? Can we do the in a national vital statistics report? Also on the national vital statistics report, I have a p-value of 0.05 and you got 1.01. Would my p-value be reject? So I have a p-value of 0.05. So it sounds like you might reject Iris. So when we reject, let's look at Iris's question first right here. Yeah, you bet. I don't think we've done that one yet, Julia. So let's do that one. We did a bunch this morning. Let's do Julia's and we do the radioactive one. You bet. Let's do a whole bunch of these. You ready? Let's just jump into it. We're going to start with addressing Iris's question. Thank you, everyone. Got started here just a moment late. Do the Prime Minister one. You bet. You know what? Let's put it to a vote. Let's go voting right here. We've got voting on Prime Minister. I'll let you vote twice. Allow multi-voting. I'm going to put it to a vote right here. Voting on question. So we got Prime Minister, Radioactive. Which other ones? National Vital Statistics. I think, is that it? I'm going to address Iris's question. Oh yeah, I did so quickly this morning, probably. Sorry. I was speed running it. So go ahead and vote in the chat if you want the Prime Minister, the Radioactive, or the Vital Statistics one. It's a twin one. Is that the Vital Statistics one? I went and grabbed some lunch real quick. Sorry about the late start. I ate some Triscuits and I got some more coffee. Sorry about the late start. Coffee, not enough cream. People are voting, so whatever you vote, we'll do them in that order. You can do 2 votes. You might actually be able to vote twice for the same option. Make sure you do exclamation mark vote like Ansley did right there. Whenever you reject the null, you always want to look at your p-value is less than alpha. So when you reject the null, your p-value is less than alpha. I think, is one of those the nonprofit? Is one of those the nonprofit? I'm trying to remember when the nonprofit starts out as. It's pure and even vote right now. No. No, we have to win out on something. Next vote wins it. Whichever one the next vote is, we will do. Whichever vote the next one is. Write the equation, you got it. We'll do that here. We'll do 2 stat to 1s, and we'll do a 320. You got it. Write the equation for the lots of sulfates lines. Oh, did I write sulfates and I meant chlorids? I might have meant lots of chlorids. I think I meant lots of chlorids. I think I'll double check right here. I'll have to check that, Kayla. That might be an issue. I haven't done the nonprofit. Let's do the nonprofit one. I think that's a good vote right there. So we got a pure, even. We'll do more. If I haven't done the nonprofit one, that's a great choice. So let's do the nonprofit one because it looks like I haven't done that one. So let's go ahead and do the nonprofit one. Let's get started. Over here, nonprofit. We haven't done the nonprofit one. And that's a good choice to do if we haven't done it. We did that one this morning. With that one. With that one. And nonprofit. Okay, we haven't done the nonprofit one. I don't remember doing that this morning. So there's an excellent choice right here. And then we'll keep doing more. It's a tie between everything. So Iris, good choice right here. Not doing it is a great reason to do it. So let's go ahead and take the question and let's identify the notation. So in this question right here, the first thing to do is identify the notation. So help out with the notation. We can get so many done. Let's try to get as many done as we can right here. We're going to do 2 201 questions, then we'll do a little 320. And I might have an error, Kayla. I might have misstated a variable. Can anyone identify any of this notation right here? I'll go ahead and start writing the equation. And your job right now is to start identifying the notation. There's additional notation that is missing. At least it doesn't tell you. Well, yeah, this one's, I'm trying to think where we're missing. Oh. So N, great job. There's the sample size. There's that. Great job. Good practice. What else we got? P naught. P naught is the hypothesized. So once we find P naught, we find Q naught. Q naught is this right here. Good practice, everybody. Great job in the chat right there. And P hat, yep. Great job. That's the sample proportion. So the sample proportion, so this is X right here. Always go through and identify as much notation as you can. The more notation you identify, you'll know which formula to use then. Great job, Iris. Excellent work. Let's throw out some points. You bought some weight, right? Points, add viewers. I was like, I'm not going to give out 100 points bonuses, and I start doing that this semester. Oh, jacket. So, and that should be right up there, the complement of the true proportion. And the complement of the hypothesized proportion is the complement up there, Q naught. And so now we plug in, and let's plug in the numbers. And so p hat, what is p hat? I've got the calculator over here. P hat is 134 divided by 1798, and it's 0.07. And when I do this, one big thing I do is I always carry through all my numbers. So you'll see me resolve this here in a moment, but I always carry through all the decimals. So you'll always see me carrying all my decimals. It's just a good practice when you're solving problems to carry all your numbers to the end. If this was a class where we used R, I would do this inside of R, because then I could easily carry all my decimals and I wouldn't have to worry about it, like writing it down. But we don't use R, so I realized that I've done problems in R, but sometimes I'm like, students aren't going to be solving it in R, so I don't want to solve it in R, because you don't have R on your computer most likely. So we're solving the bottom portion of the equation right here. And there's that. So that's that right there. We just solved for this number. And now we're going to copy it because we're going to take the top portion. I'm resolving for p hat right here so I can get all the decimals on it. So that is p hat with all the decimals. We're going to subtract this right here. And then we're going to take the number that we still have in our copy and divide by it. So that's Control V right there to copy by that number. That's an amazing z-score. I love it. Negative 2.96. Now, the reason I love this z-score right here is because when we graph this out, which is step 3, this was step 2 right here. We didn't do step 1. Step 2 is solve for that. Step 3 is solve for the p-value. And step 4 is reject or fail to reject. So when we do step 3 right here, we're going to go down here and go 1, 2, 3, and our results are right here, about-ish, and there's the p-value. So it should, and are we doing the does not equals? Let's see what it says. Is there evidence has been effective? So they're trying to lower the dropout rate. So they're asking, has this been effective in lowering the dropout rate? So the null hypothesis, which we should start with, is that the dropout rate is going to be the same. The dropout rate, so we have the proportion of students who drop out, is going to be the same as what it was in the past. If this program is effective, the proportion of students who drop out will be lower than what it was. On the vital question, how do you find Q naught when it's not given? So P naught and Q naught will always be complements. Great question right there, Bailey. We always do 1 minus P naught. Does that make sense? So the way I found Q naught right here is I take P naught, 0.095, there's P naught, and I do 1, I do 1 minus P naught right here, and that's it right there. You could get a z-score of that. That is possible. Whatever z-score you get, where do we go with our z-scores? That might be correct, Iris. That sounds maybe about right. Is it the same problem we're doing right here? Is your numbers must be closer than mine then. You must have about 8% here, or 8.4% or something, 8.5%. Your number's going to be closer to this right here. And MuBot's telling us to go to the Z table right here. So let's go ahead and bring up the Z table. And we're going to take this value right here, or I lost the screen on it. We're going to take this Z-score right here of negative 2.96, and we're going to graph below it, negative 2.96. Now, why are we graphing below the Z-score? Why are we graphing below the Z-score? Why are we graphing below the Z-score? So it's very important to know why we're graphing below the z-score. And it's possible. Oh, and yeah, that does make sense. If it's very close, your z-score should be something like that. You have 11.8% and got it. Then if your z-score, are you saying that's your p-value, Maggie? Is your p-value 11.8? If your z-score is negative 0.38, you're a little bit below the hypothesize. Did they hypothesize like 12%? So your z-score is negative 0.38. You'll have a high p-value. And they must have hypothesized around 12%. Does that sound about right, Maggie? Is yours hypothesized? Hey, Megan, good to see you here. If looking at what you have right there, Maggie, it's hypothesized is 11.8. And then what was your sample? Your sample has to be something like 11.5 or 11.4. Your sample needs to be pretty close to that because you're not that far below it. So your sample would need to be like 11.4 or 11.5. I don't know exactly. It depends on a lot of different factors, but it should be pretty close to that because you're very close to it. You should be below it. The sample proportion should be below it. But does that make sense? So your sample proportion should be a bit below it. And then where do we go once we get the z-score? Where is step 4? Step 4 is to do what? Step 4 is defined, or step 3, excuse me. Step 3 is to do what? Yep, that sounds about right, Maggie. Yep, that at least it sounds right. Because I was saying it should be about that. Step 3 is to find the p-value. So the p-value here is very, very what? The p-value here is very, very what? It's very small. So remember the null has the equal sign, so narrow it down to the ones that have the equal sign. Hey, Kinga, good to see you here. We're doing less than because we're saying, has it been effective of stopping students from dropping out of school? The test statistic, negative 2.96. The p-value here, round to 4 decimals. I might need to double check my work. We have it right here. It says 2 decimals, so 0015. If it does not accept this, I will just go crazy. Has the tutoring program been effective? Yes. We reject the null hypothesis. We have evidence that it has been effective. So the school's district observes a dropout rate that would be unusual if the dropout rate was still 9.5. Conclude that the tutoring program has been effective. 100%. That's what we like to see. So how's everyone doing on this one right here? Make sure to follow through. We've got all the notation marked. We even drew a little curve, what we should see when we go to the David M. Lane applet. Always try to draw a drawing of your curve. If you notice, you'll always see me doing this to be like, the p-value should about look like this, and take a look. Can I get it on the screen at the same time? Oh, I almost could. So there we go. If we look at what I drew and what's on the screen, you'll see it looks about like that. Like that little area to the left of where we drew is what we should have. And that's the practice that really makes sure that you have the exact thing. Which one should we do next right here? So we found the z-score. Then we plotted it, and we plotted to the left because of this right here. The reason we go to the left is because we are doing a less than alternative. So what problem should we do next? First vote wins it, even if it's one we've done. What problem should we do next? First vote wins it. What problem should we do next? What problem shall we do next? Look at assignment manager real quick. Which problem shall we do next? Ooh, it's due tonight. Which problem shall we do next? Prime Minister 1, you got it. Prime Minister 1, first vote, you got it. And then we're gonna do a little 320 after this. So don't leave. I already closed it. The Prime Minister 1. Oops, I did the preview. If I do a preview, it doesn't show me all the questions. Here we go. Replace questions. Is it this one right here? Is it this one right here, Ansley? Is it a political ad? Throw a political ad. Is it this one right here, Ansley? Monitors, aspects. Is it this first one? We can talk about this first one. If it's not this first one, we'll... Wait, let me put a cut in the video. Cut in the video! Yay! Cut in the video, so that way I can find this later. Okay. After the political ad, pollsters check the Prime Minister's negatives. They test the hypothesis that the ads produce no change. Yep, we'll do. We're going to do a little 320 after this, and then we'll come back and do that. So with this right here, this is their p-value. The p-value is going to be the probability. Yep, let's do that. The probability of our results or results from our stream happening by random chance variation given that the null is true. This is a perfect interpretation of said p-value right behind my head. This might be confusing to ask, but for PO, sometimes when you divide it by 0.20 and other times, we always use the proportion. Bailey, does that make sense? We're always using like the P naught can only be between 0 and 1. It can only be between 0 and 1. So if it's 2.8%, it would be 0.028. So if it's 2.8%, it'd be 0.028. And let's find the one that Which one are you wondering about? I could check out another question after this. Is it this one right here? Right out. Yeah. All right. Here we go. You got this. You ready? So let's talk about some null and alternative hypotheses. Good Zero Grace. Let's talk about some null and alternative hypotheses. Here we go. The null always has the what? The null always has the what? There's a trick we can use for all of these. The null always has the what? The null always has the what? The null always has the what? This is something you should just be like, the null always has the what? We can solve half this question really easily. The null always has the what? Equal sign. Yep. Boom. Half the question solved. Null always has the equal sign. So the alternative is going to be the evidence-based claim. They are trying to see if these ads have been effective with the positives. So he's paying to keep his positives, or they, who know this person is, they are paying to keep their positives above 32%. So the campaign organization would want to see evidence what? That his positives, theirs, hers, whichever positives this is, a president, sometimes it says a dictator. They're trying to find evidence that what? They want to show evidence that what? That the positives for this individual are what? They want to show evidence that the positives for this individual are what? They'd really love to show evidence that the positives for these individuals, they were saying, we're looking for evidence for the alternative that the positives for this individual are what? They're saying we're looking for evidence that the positives for this individual are what? Let's look at the part I've highlighted up here. And then which of these would relate to the alternative? We're looking for evidence that we want to keep their positives above 32%. So the alternative states that the proportion of positives for this president are what they're trying to find evidence for. So what would they be trying to find evidence for right here? What would they be trying to find evidence for? Because the alternative is always the evidence-based claim, what we're trying to find evidence for. So they want to find evidence that the positives have remained above 32%. Not less than, but greater than, They're trying to show evidence that the proportion, great job right there, Ansley, don't worry. We're here to just practice. So we're looking for evidence that the true proportions for this president are greater than. Sometimes it's negatives and they want to keep them below, so it can switch. So they'll change the question and always look for what they're trying to show. They're trying to keep the positives above 32%, so that's what they're looking for evidence for. When we ask if a six-sided dice is fair, we're asking if it is either equal to 1/6 when we roll the dice, like we get the number 1/6 of the time, or we do not get the number 1/6 of the time. So that's the does not equals alternative. Only about 25% of people who try to win more friends succeed. Sellers of a motivational tape claim that listening to recorded messages can help people succeed. Let P be the proportion of people who try to win more friends and succeed. So the motivational tape is claiming that more people will win friends with their tape. So the motivational tape is trying to tell you, I'll let everyone do the last one here, but they're trying to tell you that the proportion of people who use the motivational tape who try to win friends will be what to 25%. So they claim that listening to their tape will help you. Not listen, though. They're trying to say that the true proportion of people who try to win friends will be greater than the kind of proposed amount. Like we're trying to say, does that make sense, Ansley? They're trying to say that it'll help people in winning friends. This will help people succeed in their goals, which will increase the proportion. So the true proportion of people who try to win over friends. Yeah, let me put that in the list in case people are. Sometimes I forget to put those in the list. It should be under the videos. I'm gonna do that really quickly right here while we're between questions. So let me go between questions and let me mark these videos really quick because did I do them for yesterday's? Wait, I called it Project Stream yesterday. And did I put this in the save to a playlist? Nope, didn't put it in the office hours. So I'm gonna put this in the office hours playlist too. This should be. Is this not in the office hours? Oh my gosh, come on, Brian. What are you doing, man? This is in the office hours. That's in office hours. Okay. 2 seconds. I'm fixing some office hour stuff. Then we'll do a little 320. So many buttons to click. Okay. So if you go to the list, and we're about to hear Brian double up. Okay. Office hours. Cool. And so Emily, we'll have this fixed in the playlist. So it's always under videos. And then the office hours playlist I'm fixing right here such that project help stream over there's 13th afternoon. Move to top. Move to top. Move to top. There we go. So here I'll show real quick on the channel. Okay, here we go. So if you're ever looking, just real quick right here, you can't see real quick, but now you can. Okay, if you're ever looking on the channel, awesome. Thank you, everyone. And then, so Emily, I'll show you where it's at right here now. On the channel, if you ever go to videos, you can see all the recent videos streamed 2 hours ago, like this right here. So if you're ever looking for it, yeah, is that one we just did? We can definitely do that one here in a moment, Grace. We're going to do a little 320, and then we'll do it. Yeah, Ansley and Grace want that one. We will do that next. We'll do a little 320, and then we'll come back and do that. So we got 9 people watching right now. Thank you, everyone who's watching. Under the playlist, you can see I just updated the Office Hours playlist. There it is. So the Office Hours playlist does have, there's me talking right now. Brian Inception right there on the screen. So does this make sense to everybody? I usually try to keep this as updated as possible with all the office hours. And but also if you're ever looking for a recent stream, you can always just go here to videos and it will show you the most recent video. So let me just drop this in the chat. Here is this morning's. So for Emily, here is the morning stream, just in case you can't find it. There we go. Awesome stuff. Let's do a little 320. Put a cut in the video right here. Okay, so Kayla and everything, let's take a look. The lots of chlorids, right? We might be updating the assignment. You're welcome, Hannah, anytime. Glad to help out. That's what we try to do. Try to help out. We got these. Okay, let's take a look at the assignment. Okay. I think I made an error. Kayla. I think it's supposed to be lots of chlorids, not lots of sulfates. And I think someone was asking about that earlier, and like when they were mentioning it, and they were like, "Oh, it's not a categorical variable." We will need to send out an announcement about that. And that's what happens when I'm writing the assignment at like 2 a.m. Yeah, it should be chlorids. Chlorids is a categorical variable. Kaylin, if you have more questions, let me know. So this should be lots of chlorids. Chlorides. What are chlorides? Yeah, and then that's right. Yeah, I think that's the only issue. Yeah, that makes sense. TAs are probably like, what's going on with that? Who'll answer? Yep, we've been doing lots of chapter 15. We're going to hop back into it in a moment here. And thank you, everyone, for hanging out here. And Kayla, keep asking more questions. So it should be lots of chlorides. Write the equation for the lots of chlorides line. So what you're looking to do, and a good thing to do a lot of times, yeah, definitely. Which one are you really struggling with, Kayla? I've got the equation. I think I left this in here by accident, so helps out to have it in here. Explain the coefficient of the interaction, how it impacts the coefficient of sulfates. Oh, let's just talk about that here for a moment. Okay. So, ooh, I like this a lot. Is this what you're getting, Kayla? When can we expect Project 2? They have about a week to grade it, Kinga. They have about a week to grade it, but they usually wait till Friday, like after Friday it turned in. Probably, I would hope everything is graded no later than the 25th. I know that's a while. It's 10 days from now. They're going to have their finals coming up too, and so I'll be emailing them if they don't do it. Looks like yours. So where is sulfates the weakest right here? Looking at this graphic, just look at it visually. I don't want to go into too much detail, but I'm going to kind of talk about it a little bit. Where is sulfates the weakest relationship? Which I really like the way this graphic looks. You bet. We're going to do we got a lot of chapter 15. You bet. Great job, everybody. Really great questions. Drinking coffee right now. Coffee. Where is sulfates the weakest? Does sulfates have the weakest relationship? I don't want to go into too much. I think I might spur some I think I got it now. Where's sulfates the weakest? For which line? Weakest in terms of it really doesn't impact the alcohol content in the wine. So sulfates would have a very Little, exactly. So little is the reference. And so I can tell right here that the interaction is positive because this is the reference slope, which is actually kind of just barely negative. If you look at the reference slope, because whatever the slope is for this line is the starting out slope, and then the interaction will make it more positive. So we should have a very, very small negative slope for sulfates. So if I go look at the summary of this model, the slope of sulfates is going to be very, very small negative, and that is correct. And that's what we see right here with this black line right here, which is kind of the reference slope. That's the one way sometimes I like to refer to it. So that's kind of the reference slope. And then look right here, this is the interaction on it. The interaction on it is it becomes more positive when we switch to this line right here, because this is what would go in place. Like when you're solving the equation, Kayla, what would go in place right here? What would you put mathematically in place right here? So there's a very weak relationship. When chlorides are little, the relation, like the relationship is very weak. I'm kind of interpreting the whole thing right here. Like I don't want to give too much. I don't want to say correct. You'd put a 1 right there. If chlorides are lots, you'd put a 1. And then the relationship when chlorides are lot becomes more this and is water. Does that make sense? You could also mention the slope. The value of the slope starts out as this, which is negative. But when we have chlorides lots, does that make sense? Exactly. Is it making sense mathematically and visually what's happening here? That you have like a basically non-existent relationship that is barely negative. You bet. We'll take some votes right here. So I'll name off the numbers in chat. And so only vote one time, but I'll name them off here because we got a lot of questions people want. And thank you so much, Amanda, for coming by. Everyone for coming by. We'll definitely be doing those here in 2 seconds. And we'll vote on it. And then you'll get to pick. So an organization monitors many aspects. I think, do we have that one on our list? Is this making sense, Kayla? Like how to interpret this? With the one line and the other line, how the interaction changes, how sulfates impacts. Yep. Awesome job, Kayla. Great work. Thank you for starting early. Anytime you're stuck, just ask those questions. Great job, and I'm sure people are going to be using this later. Okay, everybody, let's bring up our voting again. We're going to do some voting. Thank you, everyone, for being here. Let's see. We did Prime Minister. A startup company. So we got startup company. Please name right now the questions you want us to do. I'm going to put them in the vote. We've got startup company. So name the question, and you get 2 votes right here. Project grades should be back no later than the 25th. I know that's a long time. They get 7 days from the last turn-in. Organization monitors. So we've got organization monitors. They have their finals coming up too. So airline luggage. I don't think we've done that one. No, we did that early, I think. Airline luggage. 1950s. Okay, so whichever ones have the highest votes right now, we'll go to the main screen. Whichever one has the highest votes. Twins, we did the twins one earlier, but here we can put it on here. Okay, here we go. So you get 2 votes, whichever comes up the highest. So there we go. Whichever comes up the highest, we will do. So you can vote up to 2 times, exclamation mark vote, and then the option you want from 0 to 4. So go ahead and vote. We'll give it just a moment here. I'm going to give it 30 seconds. You'll hear the noise when it ends. So 30 seconds. We'll just relax right here with a little bit of music. So you can vote up to twice. You might not be able to vote the same option twice. I don't know if I put the multi-voting on, but so if you do have a second one, we'll do them in order of how they appear. So make sure to vote. Did you register that vote too? It should. I think it did register it. 1950 graduates went out. Remember, you can vote twice. So vote for which one you want, and we will do the option you pick. Oh, there's the vote. We're doing 1950s graduates first, I think, unless we have another vote that comes in and it jumps up. So then actually Grace's vote might increase it. Or Grace's vote, I think, is actually the one that made Startup Company go up to 3. So it's Mubot. Mubot's actually in like the future. It's weird. I don't know. He sees things faster than we do. So let's hop back here. Let's do 1950s graduates and Startup Company. Thank you everyone for voting right there. Helps out. Okay, let's do some 1950s graduates. Cutting the video. Oh, Startup Company won. Clarissa, you just chose Startup Company. Clarissa was like, I'm waiting till the moment. How do you vote? You just pick, you do exclamation, do you see how they're doing exclamation mark vote and then the option? So you just pick exclamation mark vote, and then the option. Sorry, I took them off the screen right here. I'll show them here in a second. Or Mubot actually has them listed up there if you look at the chat. I'm finding the startup company one. Where's the startup company? A startup company, we got it. Let's do this. I tried to see what was on my quiz. Like, wait, 2 seconds here. Okay. A startup company is about to do a new marketing campaign. They want to see if this marketing campaign is a good idea. And so here we go. Let's take a look. Oh, make sure there's a space, Amanda. So make sure there's a... Don't you... yeah, after the 4. Did Mubot register those? I'll see if Mubot listened. Mubot? So make sure there's a space, and then you'll see these go up right here. So make sure exclamation mark vote, and then a space, and then the number. And then Mubot will hear. He listens. He's good.
I am Mubot.
Mubot, chill out. Chill out, man. He's so mad these days. We took away his happy voice. Now he's just mad, Mubot. Okay, let's take a look at this question right here. Here we go. So what do we see right here? Step 1 is to write the null alternative. Let's do this step by step. So step 1. Step 1 is to write the null and alternative. Sure. To write the null and alternative, the null always has the what sign. The null always has the what sign. The null always has the what sign. Whenever we write a null, null always has the equal sign. So null is always going to have the equal sign. So we know that. And what are we testing right here? We're testing the proportion of people. The goal is that the company has over 39% people recognize its brand. So it's the proportion of people who recognize a brand. So that's why we're going to put P right here. The proportion of people who recognize a brand, and they want over. What is this going to mean right here? Who can tell me what this means for the alternative? And this will be the hypothesized value. 39% is the hypothesized. But what does that over mean? Abby, you're cracking me up. It means greater than. And then so 39% is the hypothesized. This is actually P naught right here. But we're gonna put the actual value for it. So there we go. So we're gonna say that the true proportion of people who recognize this brand is greater than 39%. The null is that it is 39%, but we're trying to find evidence that more than 39%. So with this right here, we've done step 1. We've written out the null and the alternative, and now we need to go here to step 2. I've always hated that it won't let me. Okay, let's do step 2. That works. Step 2. Step 2 is going to be solving the mathematics right here, solving the model. We need to make sure it's random, 10%, and then we have success failure, which means we have at least 10 successes, at least 10 failures. If we know that P naught is this, what is Q naught? Practice along. Thank you, everybody, for practicing. What is Q naught? I always try to remember that I've solved so many of these. A lot of times it's very easy for me, but it's all right if you say, wait, how did you find Q naught? A lot of people will wonder, how did we find Q naught? And finding Q naught is 1 minus P naught. So great job, Lauren, right there. It is 0.61. Exactly. And so now we have the last few things. X is the number of successes. N is the number of trials. P hat, which is the sample proportion, is X over N. So we're just going to get here the sample proportion. And the sample proportion is 179 divided by 403. And that's a nice number. There we go. So now we have the sample proportion, what was observed in a sample. So now we need to solve the equation, which is going to be the z-score is equal to p hat minus p naught over p naught q naught over n square root. And this right here, we just plug in the numbers. And there we go. That's going to be a smaller, it's going to be a z-score of 2-ish something, 2.8. Oh, that's going to be sad if I got it right. 403. There we go. Let's solve the z-score, see what we get for the z-score. The z-score is going to be positive. Just make sure when you type it into the calculator, I'm a little afraid. I saw a digit appear really quickly, and I'm like, I hope I didn't mess that up. There we go. And I'm going to resolve for p hat so I can carry all the decimals. You'll often see me redo that because I just like carrying all my decimals. I wonder what I guessed. I feel like I guessed something like that. Maybe it was a little bit off. We might. I think that we'll look and we might revote or something. We got a second one lined up right after this, but Ansley, we can definitely put that in the list, and we'll do some voting here. So if you're here watching live, you can always vote, and we'll always do. We're just going to try to do as many as we can, and we've got the z-score right here. From the z-score, what are we going to find next? Once we find the z-score, what is step 3 now? We've now found the z-score, so we have the z-score of 2.23. So we have the z-score of 2.23. What do we do next here? Once we get the z-score of 2. It's a bummer. Thank you so much, Lauren. 100 points right there. Even pulling up the David M. Lane in the chat. Lauren, just A+ work right there. Thank you so much. That's what we want to do. So we want to find. Really. Now we want to go there and find the step 3 p-value. So now that we have the z-score, I'm going to do a quick drawing of it right here. Since we are doing the greater than alternative, we know that we are shading to the right, and the p-value is going to be, this is not an accurate drawing, but the z-score is equal to 2.23. The p-value, I know, great job right there. So we're going to pull up the David M. Lane. Yep. King is on it too. Mubot, I think he will say, wait, a little more time and I'll pull up the David M. Lane. 2.3263, 1%. This is between 1 and 2.5%. It has to be. Don't worry, you're not supposed to know that off the top of your head. I'm giving a p-value estimate of about 0.018. That's my p-value estimate. I know Mubot's not listening right now. Mubot, you just chill out, man. He didn't want to talk. He's mad today. Mubot, what's the problem? That was close. This was a guesstimate right there. I thought about 1.8%. The p-value is 1.3. Look at, we put, just so you're not confused with this, we put in, we're graphing to the right because it's a greater than test. And we're just finding the probability of our observed result, which is right here in a z-score format, or a result more extreme than it, happening by random chance variation given that null is true. So that is the p-value. And so let's put in the decimals right here. That was a guess, close, decently close to it. And so now step 4 is to do what? As long as we're not using a weird, oh, there we go. There's the alpha level. So they're saying alpha equals 0.05. So now step 4 is to do what? Since we know our alpha level right here is 0.05, step 4 is reject/fail to reject. And we only have 2 statements right here. We only say, I reject the null or I fail to reject the null. And I have that written down earlier. Yes, here it is. So we only say, I reject the null or I fail to reject the null. And in this instance, our p-value, the z-score is the test statistic. Yep, that great question with our Grace. The z-score is the test statistic. And so we are going to reject the null because the p-value is less than 0.05. So with the low p-value here, I reject the null. I have evidence for the alternative that this campaign is creating more brand awareness. So let's go through. So we are definitely going to reject the null. Low p-value right here. Low p-value means we reject the null. We have evidence for the alternative that we do have more brand awareness by doing this campaign. So we saw that the null has the equal sign. Well, that makes life easy. Oh, wait. Something's weird here. Were they trying to lower it? Oh my gosh. What happened? What happened to my brain right there? I was like, I didn't see the second equal sign. I only saw this one. But they're trying to find evidence that it's greater than. I almost got tricked. That's not good. The test statistic is the z-score right here. It wants 2 decimals, and I think that's still what we found, 2.23. The p-value right here to 3 decimals, and we needed David M. Lane for this. So I believe, where's David M. Lane with our p-value right here? So 0.013. And there we go. Would you recommend the company continue advertising? Yes. There is evidence for their alternative. Yes. That's what a great scene. It is greater than. Sorry, Lauren. I misread it, and I was like, I literally, when I was looking at this, I don't know what my eyes saw, but I saw this as a greater than sign or something. Like when I saw this, I swore that was greater than. And then I was like, oh, there's only one equal sign. So I was like, it has to be this one. And then I was like, but that's less than. And then I looked down and I was like, wait, that's greater than. Wait, that's that. Yep. I know it's so easy to like. That's why you get 5 attempts, because even, I think it was Monday, I made 2 mistakes. Today, wasn't there? Oh, I speed ran one at the end of office hours, and I was doing it super quick, and I misread something. It's very easy to make mistakes. That's why you like double check, be like, oh, wait a minute. If you notice, one thing I want to point out, and let's see what the vote's at. We'll do the other one that got the high vote, then we'll revote. So we just did a startup company. We'll do the 1950s graduates because that was the second highest vote. It's very easy to just make mistakes on these. Here we go. Let's hop back to space. We'll do the 1950s graduates. Where is it? Am I going crazy, everybody? An organization monitors. Let me go and let's take a look at it. Am I not seeing? Oh, wait. Oh. Here it is right here. Here it is. Sorry. Okay. Yeah. I think it says this right here, right? Sorry, I was trying to find it, Ansley, and then I found it in that moment. So here it is right here. So let's think about this right here. We're talking about people graduating from high school. Has this percentage changed? So when we do this right here, when we write out a null and alternative, and I think I've still got some notes up for this. When we write out a null and alternative, the only things that can go in here are P, at least right now for our class, because this does not apply to all statistics, but we will use P, mu, or mu1 minus mu2. They're not going to give you all these options, but this alone will narrow down some of the options for us. Like seeing this, that we can only use P, mu, or mu1 minus mu2. What are some wrong answers right here instantaneously? Like, what are some wrong answers? Good to see you here, Carson. I think we can do atomic. We haven't done atomic bomb lately, I don't think. Do we? We'll revote after this. We'll revote, and then we'll see what wins out. So with this right here, y bar is not an option. We don't talk about the sample mean with the null. And also p hat. So we're between mu and p. Now, why would we pick mu or p? More mu or p. So why would we pick mu and why would we pick p? And there's an answer for which one we'll pick right here. Why would we pick mu and why would we pick p? Which are the only 2 options we can pick by how we're doing things. We'd either pick mu or p, and later on we'll have mu1 minus mu2. Question 15, homework. You should be using David M. Lane. I believe so. Oh my gosh. Does MoveBot respond to that? You are correct, Lauren. That is correct right there. You will use P right here because it's proportion, and that's true proportion. And then the null has the equal sign. You know what? Let's just make our lives easy right here. The null has the equal sign. This is about 20% of cars the manufacturer hopes to redesign. That's a percent. That means it's a proportion. We want to find out over 60%. That means this is a proportion. And now here's the really good thing. Whatever we put for that spot right there, let's go back to this. Whatever we put right here also goes down here. Whichever alternative we pick, it would also go for, oh my God. Whichever alternative we pick, whichever thing we pick right here goes right here. Does that make sense? So if we pick P here, P goes here. So by virtue of knowing we picked P here, P goes here. So we've answered that. So these all have to be, because we picked P here, P goes here. Because we picked P here, P goes here. Because we picked P here, P goes here. Also, the same number goes here, because that's the hypothesized value. Let's look. Has the percent changed? Greater than, less than, or not equal to? What does this sound like right here? Has it changed? Greater than, less than, or not equal to? It can be over 1. That's slightly large. Not equal to. Yep. Not equal to. The manufacturer hopes to redesign has solved the problem. So 20% of cars need transmission work. So they probably want to, if they're trying to fix this, this is not a good thing. So they're trying to fix this issue that 20% of their cars need transmission work. They probably want the proportion of cars that need transmission work to be what to 20%. If they're trying to fix this, so they'd want evidence after doing this, whatever they're doing, that the proportion of cars that need transmission work, the true proportion of cars, like for our cars, the proportion that need transmission work is going to be less than. They're trying to find evidence that less than. And it's always less than, greater than, or not equal to. Do not be tricked by these other ones. Those we don't use. I've always hated those. I've seen people use them. Don't use those. Don't use those. We field test a new soft drink, planning to market it. If we are sure over, ooh, this one's obvious. We got this. That one right there makes the claim. And what is the claim? Great job, Grace. What is the claim that they're trying to look for right here? So always look to the question to know the sign of the alternative. So the question will always, and if the question doesn't make it clear, then you would use not equal to. But that one almost not going to clear. That one is making it very clear what it is. If the question is like, is it true 60% of people like this? Then that doesn't give an alternative, so you would choose does not equal. But this one is making a claim. So we're trying to see that over 60% of people like the soft drink. So we want to see if there is evidence, because that's the alternative, evidence that the true proportion of people who like the soft drink, they want to see more. They want to see that there's evidence of that. So they want to see greater than. Great job. Lauren, is this making more sense in everyone? Is it like being like, yes? Oh, yes. Great work. Even I'm like, for the dataset EX6 wine, are all the quantitative variables in terms of percent? That's a really good question. Adam, so good to see you. Thanks so much. Happy Haslam Friday. That's a really good question. I can get back to you on that. On part 1, task 1 is the model we make LM or GLM? LM. Great question, Cora. The first one's an LM. The second one will be a GLM because the first one's just a linear model. And technically, you could make it with GLM, but the graphing features Dr. Petrie created won't work properly. That's on my list of things to update. It's been on there a while. GLM can do both linear and nonlinear models, but LM is only for linear models. GLM stands for the generalized linear model. Great questions right there, Cora. And thank you everyone for working on that early. So you can, but the first one is an LM. The second one is a GLM. So the first one can be an LM. The second one cannot be an LM and must be a GLM. Which of the following hypothesis, you're welcome, Cora. Following hypothesis has the appropriate form for null hypothesis. Would it be, that sounds right, Ansley. The null always has the equal sign as long as you're, hey, Alyssa, you're welcome. Glad to help out, everyone. Let's take another vote. Let's hop, we'll put a cut in the video. We'll take a sip of coffee. People were talking about the radioactive one. Radioactive. Let's remove the 1950s. We'll stop the voting. And we need to put radioactive on here. We will reset the votes. Radioactive. And so I don't know if there's any other ones we haven't said yet. So let's reset the count. Where's reset the count? Can I not? Oh yeah, we'll keep the votes on there. Okay, they get to keep their votes. Oh wait, there's the reset. Reset. Here we go. Okay, so we got the poll up and going. I like it. It shows that I think 14 people are watching. So take your vote now and go ahead and vote for the option you want. These are the options I remember people saying. We got airline luggage vote right there. You can vote twice, actually. So you can vote twice. I put on the multi-voting. So you can vote twice. We'll see what vote. I love this right here. What do I do with that? What do I do with this? What do I do? So feel free to vote twice. We'll let this go for another 30 seconds. I'll pick the top vote at 30 seconds. So some chill music. Twins is winning out. You can change. So Clarissa, I think it doesn't accept the same vote twice, but maybe it did. Oh no, it might have accepted Courtney's vote. Twins is winning. It looks like Twins is going to win. We'll go ahead and start getting Twins pulled up right here. You're welcome, Abby. Might do radioactive next, it looks like. Your vote matters, especially with so few people here right now, or so few people voting. There's the vote, and it's Twins. You can keep voting in the background. I'll keep that up. Let's get the Twins problem up. Where's my Zoom? Mubot. There's so few people here, Mubot. would be little bonus questions right here. Null. There we go. Fix those questions. Which one we say? We said twins, right? We never accept the null. We don't accept the null. We just fail to reject the null. We didn't put luggage on there, did we? We did luggage this morning, though. Here we go, twins birth rate. Let's put a cut in the video. Time to do the twin birth weight problem. Let's do this. Hopefully I found that cut in the video. Okay, so here we are with the twins birth weight problem. Let's identify... We'll do the steps right here. We've been doing a lot of practicing the steps today. And... so let's go right here. Let's write the steps. Step 1. Null and alternative. Step 2. Find test statistic. It's called model in the notes. Step 3. P-value. Step 4. Reject/fail to reject. Okay. Okay, here we go. You ready? With step 1, we write out the null and alternative. So in this problem right here, we have that previous reports report that 3% of people have twins. We want to see if this is the same for very young mothers. So we're asking, is this the same? Now, what is, and this will help us for later, what is 3%? A lot of people forget what this is in notation. I've maybe given a hint by circling it. What is 3% in notation? So we're saying, basically, people hypothesize or propose to us that it is true that 3% is the birth rate of twins. 3% of births. My gosh, like if Chelsea and I ever had kids, if we ever had kids, we'd be the parents who like had triplets. We'd be like, let's have one kid, and then we have triplets, and we're like, oh my gosh, now we're taking care of triplets. That would be what would happen to us. It'd be crazy. One of my friends from college, I think he has kids, and his kids are like 15, 16, and I'm like, oh yeah, I'm almost 40. Ha. No. Why? Making me feel old there. What do we have right here? What do we have here? What is 3% in terms of notation? Little chill music. What is 3% in terms of notation? 38. Awesome. It's whatever people want. There's a set of triplets in first grade at my kid's school. They run everything like into something. Yeah, that'd be good right there. 3% is going to be the hypothesized. And whatever choices people choose to make, whether you have kids young or old, I always support people in their decisions. The freakiest thing to me was when a student once told me, they said, my mom's younger than you. I was like, what? I was like 33 at the time. And their mother had obviously had them a good bit younger because they're in college. So their mother, like, if I'm 33 and they're like, my mom's younger than you. I was like, what? She's like, yeah, my mom's 32. And I'm like, what? So, but, great job. Like, and that's like, you meet so many amazing people teaching. Yeah, older. And so, everyone has a different experience in life. It's just those moments when you start to feel old when someone says, but nowadays, if someone had a kid at 21, they'd be in college. Also, my aunt didn't have her first kid till 41. There you go. There you go. They are drilling downstairs or something. If you have time, can you go over how to explain the coefficient of an interaction? Oh, we were doing that earlier, I think. Yeah, check out earlier. Check out earlier, Cora. And if you don't know, we'll come back to it. So we have here P naught. So let's write out the null alternative. Got a little distracted. Never hurts to get a little distracted. You know what? All moms are awesome moms. As long as they're there to help you and take care of you. Doesn't matter if they're old, young. And we're asking, is it the same? So we want to see if it's different. Shoutouts to mom as Mother's Day approach. Confused on the David thing. You found the p-value, but put it in above. I think I used the outside. Double check the alternative sign. So the way we know how to shade, this is going to help us for later. is like one of those things. Or let me do the same. So double check. We might do the radioactive one next. I think that might be on the list next, Bailey. So if you wait, like, we'll do it. It might be UT Wi-Fi. No one's been saying there's major issues today. And I do have Ethernet cords that might have just come in. There's an Amazon package outside the door. So I might have new Ethernet cords. And we'll find out if it's Ethernet cords. And then next comes replacing the router and modem. Haha, that'll be an expense. So Ethernet cords are not as bad to replace. Cat 8 Ethernet cords. So when we find the p-value later on down here, whatever we find down here for the p-value, we will be shading both sides. Let me look at the thing. Okay, it's going to be somewhere over here. So because of the way we picked the alternative, I'm taking a guess of where it's at. Because of the way we picked the alternative, we will shade like this. Because when I do this, we are shading a value as extreme or more extreme. I hope it is just, I hope it's not me, because last semester we really had no issues at all. We had like no issues. And then I did see a thing on Reddit about people talking about UT Wi-Fi being pretty bad lately. So we had, last semester was like, if we had a buffer issue, it was just like random. So yeah, great job, Bailey. And that's what we're here to do, is like when you see it, you're like, oh, it's based on the sign of the alternative. So if we pick the does not equals, when we get to step 3, that's how we will shade right there. Lauren, has it been happening has semester, like this semester, has Zoom classes been buffering too? If so, then that makes me feel way better. Like, you've made my day by saying that, because then it's not me. But people have reported, maybe it's like Knoxville, maybe it's like just internet in general. I don't know. Why's the world gotta be? I don't know. Yeah, so it's, yeah, we push through, we get through those buffers. Last semester, I promise you, we had like, if we had an issue ever, it was just like random. People would be like, buffering, and I'd be like, what? We're buffering? And this semester, like in February, I was afraid we might have to make some changes. I was really worried. I was like, I am very dissatisfied. How do I find the Z statistic? Well, you'll find that right here, Alex. The Z statistic is going to be found in just a moment. Let's find this. What did Brian just find right here? Who knows in the chat right now? What did I just find mathematically? I just took x over n. So what am I finding right here? What is Brian finding by taking x over n? X over n is getting the what? What did we just find right here? Oh, that's so crazy. Well, I'm glad it's not just us. I'm glad. Well, not like glad, but like if it was just me, then I'd be like, oh, crud. What did we just find by taking x over n? Mm-hmm. This is a great one. And so we just found what right here. So this right here is the what. And I'm going to find the z-score right here, right now. What did we just find by taking x over n? It's all about the notation. That's so crazy. So it might not be me. Because sometimes people will be like, there's no buffer, there is a buffer. And so it might just be like Knoxville Wi-Fi or something that could be like, which is a bummer. I like Knoxville. What did we just find right here? By taking x over n, what did we just find? X over n is what? The number of successes over the number of trials from a sample. So the number of sample trials, p hat, exactly. Great job right there, Lauren. So that is p hat. So let's go ahead and start applying these numbers down here. And 3% is the hypothesized. And this will get us the z-score. So this will get us the standardized distance this is away, which it actually looks way smaller than I thought. Graphically speaking, this is going to, well, we can't do that to move it. This is not going to be that big of a z-score. It's going to be negative, but like closer to -1. So I way did not estimate it properly. There's that. Was it 10? And there's that, minus 0.03. And there it is, negative 0.81. So I was way, way off in my drawing. We're going to need to change this drawing. So negative 0.812, which is a pretty small z-score. One question is, do we add the coefficient? You can. You can do that right there. Great job, Cora. You can, like, the graders shouldn't be too, like, mean on it. Please tell me if you ever think the graders go too crazy on grading. But yeah, you could add it in. It's not the end of the world if you don't. Like, just talking about how it gets like stronger or weaker for lots or little chlorids. So what do people think about the p-value here? The p-value here is very what? Which this one's so obvious we can kind of see. The p-value here is very what for my question, which we'll get the numeric value of this in just a second. But the p-value here is going to be very, very, very what for Brian's question. This is you can see visually. And so since the p-value is much greater than, that is correct, Alex, yep, 0.05, we fail to reject the null. We do not have evidence that the proportion of births of twins is different for young mothers. So since the p-value here is very high, we fail to reject the null. Now, once again, we're going to get the exact p-value. I've done a drawing of it. So I've done a drawing using this z-score we got right there. We're going to go over to the David M. Lane, which should be in the chat right now, and we're going to make the exact same drawing. But we always do a little practice to make sure we can get it. And if you look at what we get right here, it should look a lot like what we drew on the screen. So my drawing and that should look very similar. And the p-value here is that, 41.66. And let's go back to the question. Let's go back. We've solved it all. Are the assumptions met? Random, 10%, and success failure. They are met. What is the hypothesis? The null is that it is equal. The alternative is that it is not equal. The z statistic was 2 decimals, so it's negative 0.81. I believe so. Let's look at our work again. There it is right there. The p-value, 3 decimals, so 3 decimals. What is your conclusion? Is this the one? Yep. I fail to reject the null. The proportion of twins is not different. I fail to reject the null. We got it. There we go. Does that make sense? And then we had another one lined up after this. What's the next one we have lined up? Pretty sure we had another one lined up. Next one we have lined up is... It is the radioactive. Let's do the radioactive question right here. Was that the one we did quickly at the end of office hours? My gosh, we've done that many already today. Awesome. Here we are. Let me put a cut in the video. Cut in the video. Helping out future Brian. Make sure to check out these videos. And I'll try to put some timestamps in soon after class, hopefully. Let's go check out this now. Okay, a radioactive fallout for testing after atomic bombs, all that great stuff. There were 240 people in the region. 32 eventually died of cancer. Yay. Sarcasm. Cancer experts estimate that one would expect 27 people. So this sounds like a what? Like they're hypothesizing this. This sounds like the amount they would expect due to random chance, which kind of sounds crazy. I don't know. That's what they would hypothesize to be true. So that's going to be our hypothesized proportion. So when we go right here, are the assumptions met? Sure, my Pearson, they're met. Random, are these randomly selected individuals? 10%, less than 10% of all people. Is there at least 10 successes expected, at least 10 failures expected? This is how many successes they would expect, and they'd expect 213 failures because it would be the complement of that, or what adds up to 240. So we do meet success failure. Randomization, 10%, I guess more likely 10%, but sure, my Pearson, we meet all the conditions. State the null and alternative hypothesis. Choose the correct answer below. So the null has the equal sign. I think we could. We'll put it on the list here, Maria, and then we'll try to do it here in a moment. We'll see. We got the list. We'll check it out. We'll give it a try. And so we have here, let's mark the notation. Who's going to help me with notation? I need help with the notation in this problem. So let's go grab the notation and let's do the steps. Who's going to help with the notation? They want to see... Assume this is a typical. So wait, how did you find the p-value for the last problem? Go to the David M. Lane and plot the outside of the z-score. Go to the David M. Lane and plot the outside. I think so. I think we did those earlier, Catherine. Check it out. And if you don't see it, let me know. So I think we did it earlier. Yes. Thank you so much, Lauren, right there. Lauren, let's throw some 50 points. Lauren helping out. And we'll see another example of that here soon in this one. Are they asking if it's unusually large? Yeah, it's unusually high. So they're asking if it's unusually high. So they want to see if the proportion of deaths that are observed relative to what they would have expected is what to this. Here's what they would expect. So they want to know, we would expect this proportion of deaths, which this is this of a proportion of this. This is what they would expect. And they want to know if it's unusually high. So which one of these would denote evidence it's unusually high, which is the alternative. Greater than. Great job, Lauren. So this is the alternative for greater than because we're trying to see if it's unusually high. We jump right into the z-score and the p-value now. So we need to do the notation. So the notation is going to help us out right here. I will do the notation for this one. We got 240, we got that, and we got this. 240 is going to be the sample size. This is going to be what they would expect. This is kind of weird. It might be x naught. So that's kind of x naught right there. That's kind of weird, but this is here x. That's how many they did observe. So at that time, 32. So x over n equals p hat. P hat is how many we expect. P hat is what we saw in the sample. So 32 out of 240. In the sample, we saw 13.333333%. Now, what we have right here is 27 over 40. 240 is what we would have expected by random chance. So by random chance, we would have expected 11.25%. That's what we would expect, which makes Q naught 88.75%. There we go. So that's what we would expect by random chance, given the null is true. And we also see that they give this away to us right here by using the following notation. They make it clear that this is P naught. P equals P naught. So this is what P naught is. Just by it being there, that means that is P naught. So if you couldn't find it up here by doing 27 divided by 240, by it being in this position, it is the hypothesized value. That is always where the hypothesized value goes. And for this problem, since we're using P, this would be P naught is the hypothesized value. Whatever goes right here is what we are hypothesizing is true, like P naught, or in quantitative problems, it'd be mu naught. So just making sure you understand that whatever is here is P naught. So by virtue of seeing this right here, that is P naught. That is the hypothesized value. So let's go back to here and let's solve the problem. Okay, we need to solve the equation. And the equation we are going to solve is going to be P hat minus P naught over P naught Q naught over n square root. And this will equal to 0.1333 minus 0.1125. And now we go down here, we square root, and we go to 0.1125 times 0.8875 over 240. This will give us the z-score right here. So let's go ahead and solve the z-score. And the z-score is going to be 1125 times 0.8875 divided by 240. Just hopefully don't make a mistake. And then we take 0.13333333 minus 0.1125 divided by that. 1.02. I like that z-score. Why do I like that z-score? This z-score we can guesstimate with. This z-score, because it's 1.02, we can take a guesstimate. Is it 4 decimals? Oh, man, that's such a hard one to guess now. 4 decimals is very, very hard to guess, but it should be something like that. That's super hard to guess. That's going to be close, but let's go look at the David M. Lane applet. We need to go to the right. Why are we shading to the right? Because we're doing above, and so we're going to shade to the right of that value. So I was off by 2 1,000ths. 2/1000ths. Man, that'd have been so cool if I had gotten exactly correct. But we're taking our z-score and we're shading to the right of it. Why are we shading to the right again? We're shading to the right because of this alternative right here. The sign of the alternative shows you which way you'll shade on the graphic. Because we have a greater than alternative, we will take our z-score. Exactly, Lauren. Great job. Correct. So we do the greater. Do you see how this like points to the right? So when you have the greater than alternative, you'll always shade to the right. Great job, Lauren, everyone. Let's throw another 50 points. This is, like I said, this is the practice. And then the sign of the alternative, that's why I slow it down right here and like show this. How do you know the interpretation impacts the coefficient of sulfates? With the interaction, I might go back, Cora, and talk over that a little bit more if you want. Going back, how do you know the interpretation impacts the coefficient of sulfates? Due to the interaction? Sorry, I'm trying to figure out how to answer it. Good questions, Cora. Keep asking, Cora, and I might go back here after we do maybe one more. I might go back and talk over it a little bit more. I think this is the one I got wrong because I did it too quickly last time. Okay. So what alpha are we using? Probably general 0.05 if not otherwise specified. The p-value is high enough, too high. Okay, here we go. The p-value is too high to conclude that the death rate is unusual. This is basically telling us what? I don't like the way this is phrased. I would just say I do what? So right here, we are saying what? With the p-value being so high, we're just saying I do what? I fail to reject the null. I do not reject the null. I do not have evidence that the death rate is unusually high. So this right here is saying I fail to reject the null. And then this is saying we don't have evidence to the alternative. They're just trying to change up the wording a bunch to turn you not into a robot. Because I would just say I fail to reject the null. There's not evidence to the alternative. Does this prove? We can't prove things with, you don't prove things with statistics. Statistics just shows evidence or does not show evidence. It doesn't say what causes and affects stuff. Yes, another 100. Only got one wrong today because I was going way too quickly. And and they didn't phrase it reject or fail to reject in classical statistical format. Wasn't there another one? I think there was one more. Wasn't there one more? Here's the ones we've done during office hours right now. And we just did question 12. So we've done all of those. There's airline. We did airline earlier today, I think. So these are the ones we have not done yet. I don't think we've done this one yet today. Let's do one more 201 and then which other ones do people want to do? So we've got an organization monitors. Oh, no, we did this one earlier, I think. This one, okay, this one gets the votes then. Everyone's saying this one. Okay, let's do it. Okay. The null has the what sign. Help me out right here. Let's do the easy parts of this. The null has the what sign. The null has the what sign. Everyone knows this. You got this. Everyone even knows this. I go up, I talk to my nephew Tolliver, and I'm like, the null has the what sign. What does he say to me? I'm like, Tolliver, the null has the what sign. He says what? He says the null has the equal sign. I'm like, man, you know your stats, Tolliver. You're pro at this. So we have here the null has the equal sign. Put on a little music. I like my chill music right here. Just chilling out. So the null has the equal sign. And they are looking for evidence that it's changed. This is where people get confused. Is there evidence? Once you hear evidence, you're thinking alternative. Like, okay, they're looking for evidence it's changed. So what do you think we would put right here if we're looking for evidence it's changed? That's what they're, don't read the part where it says it's declined. We don't look at the numbers for the sign of the alternative. We look at the research question. It's in the notes. We don't look at the numbers for the alternative. Changed is not equal to. We're seeing if it's this or not this. So we're seeing if it's not equal to this. So don't look at the numbers. I know it's gone down. But don't look at that. Don't look at that. So now we got the random and 10%. They break these apart sometimes to random 10%. I mean, random and independence. Sure, plausible. Less than 10% of all students. Sure, plausible. Now, the success failure condition is truthfully met. It's not plausible. It's actually met because we have 8,123 students. If it has remained the same, then we would expect, by random chance, to have this many right here successes. So we can do that one next, Alex. Yep. I don't think we've done that one yet. Maybe not even today. So that's a good one to do next. Let's do that one next. Remind me at the end of this in case I forget. This is 100% met because we have what? So the success failure condition states, and sometimes we just flat out ask it this way on the test. This is met 100% because I just showed how many successes we had. I'll show you how many failures we would expect to have. We would expect this many failures. So this is not plausible. This is just This is just mathematically met. It's met because we have what? We just showed mathematically via NP0 and Q0 that we have more than 10 successes. I think we might have done that one earlier, Cody. Like, and we'll do Alex's, and then I think we can do that one. I think we've done that one today. We'll double check though, because we haven't done Alex's yet. Plausible. So now we got to find a p-value. We got to find a z. We got to find a p-value. We got to find all this. Let's do some notation. You guys know I always need help with the notation. I always get stuck on it. Notation's the hard part. Notation's the memorized. Okay, identify one bit of notation. Let's get that snowball rolling down the hill. If you're watching this video in the future, try to identify the notation too. There's some harder ones in here. I think that's it. That's it for the numbers we need to know in here. And then we can derive a few other ones. What do we got here number-wise? I'll give some hints. Help out with any bit of the notation right here. I'll give one that's not on the screen. That kind of gives away what the other one is. So they're using that as a baseline right there. Ah, be careful. That is P naught. Don't worry, Lauren. And so, so this would be P hat because this came from the sample. So the way to know this is this came from the sample of this. This is connected to this right here. Does that make sense? So since that came from the sample, that would be P hat. Does that make sense, Lauren? And then this right here is the hypothesized that they are saying is true. Do not worry, Lauren. I'm throwing some 50 points. This is like what can make these questions hard a lot of times is just the small subtle differences between P and P naught and P hat. So they are saying, let's suppose this is true. And then also a great way to check, especially with these questions, is if you look right here and you see this, whatever is in this position right here is going to be P naught. So whatever you see right here, and I know this looks all crazy, but whatever you see right here is P naught. So whatever value you see in this spot, by looking at the question, 34% has to be P naught because we say P equals P naught. Which then and you might be like, well, then isn't it also P? Well, that's the assumption starting out that this is the true proportion. We are hypothesizing what it is. So yeah, I hope, who feels like after doing some more of these, the whole testing idea is starting to make sense, that we're just seeing, is this possible? Like, how far away is this from this? I'm hoping like as we keep doing more of these, it's like, oh yeah, I get it. I get what we're doing right here. We're just seeing, here's what we saw in a sample. Here's what we hypothesized true. What's the distance? And let's standardize that difference by the metric below to turn it into a test statistic. So we take what we saw in the sample. Ooh, I was like, that didn't look right there. We take what we saw in the sample. Ah, Lauren, that's awesome. It's just you do something a bunch of times. And that's the issue is it's all right. I've got a lot of memories of all-nighters before tests. I was one of the kings of all-nighters. I was one of those students, you'd see me like half awake the day and I'd be like, I just had a big test and I stayed up all night. If I could go back in time and redo how I did school, I would not focus on all-nighters. I'd focus on, okay, I need to look at this multiple times before the test. Because then, and I did start doing that later on, because when I took linear algebra and I was solving problems, I was like, wait, I'd study for the test and I'd be like, I'm just looking at this and I'm like, I know it. And because I had been working on it like a few times leading up in the weeks before the test, and I was like, oh, it's like when I go to study for the test, I'm just like, I know this. I know it's, don't worry, I'm not, I just keep debating, like reaching out to one of my previous teachers and being like, hey, do you want to come talk on the stream and talk about how bad of a student I was? And they'd be like, why do you want us to do that? And I'd be like, to encourage my students, to let them know I wasn't good at education. And I still did all right, but I just, I could have, there's a lot of things I could have done better. And so I don't want people to feel bad if you're like Brian and, using your energy late at night to be like, I'm going to ace this test by staying up all night. And it's like, you're kind of throwing your schedule off balance. What's the p-value going to be? Which alternative do we have? We have the does not equals. This p-value is going to be about 6%. There we go. Let's see what the p-value is. Now, Lauren, good practice right here. Which way am I going to shade this curve? Am I going to shade one side, left or right, or am I going to shade both sides? So which way, with this z statistic we have, which way am I going to shade the curve? And how do you know that? Well, don't worry, I'll answer how you know that because I think you'll get it. Both sides, you got it. Because this right here, great job. We're going to shade both sides. Excellent work. Great practice today. We're going to go here to the outside, and we're just going to put in the z statistic and shade, and it is, oh, I think we got it close enough. I think we were close enough in our guess. Oh, we were decimal place accurate, sure. So, hey, that worked. So now state your conclusion using the 0.01. Using the 0.10, excuse me. All you do is you look at this, and you have to be very careful here. When do we reject the null? When the p-value is what to alpha? Here's our p-value. Here's the alpha. Am I going to reject or not reject? Because my p-value is what to alpha. So this is when we reject the null. This is just the limbo bar, and here's my p-value. So I am underneath that limbo bar. We reject the null. Excellent work. There is evidence for the alternative that perfect attendance has changed. Now, this difference right here looks to be pretty small. So the difference is probably not meaningful. So this is just practical significance right here. Great job, lower than alpha. Yep. And man, we're just acing all the questions. Doing a great job here, acing all those questions. Let's see. What was the other one people wanted? Which ones have we not done today? I think it does too. We have to put things in context, like that p-value has to limbo under that bar to be like for us to reject the null. It's like, when do we reject the null? When the p-value is lower than alpha, it's got a limbo underneath it. I always try to whenever I think of these things, I'm like, how can we it just helps to have up these ideas, these visualizations in our head. So thank you. I'm glad this help out. Which one? Let me put a break in the video. Wasn't there one people said right after this? Wasn't there, or was this the one? The one question. Let's see right here. I think it was Alex. Airplane luggage, Alex said. Did I seriously just go to it and then went away from it? Let's do the airplane luggage one. Here we go. Okay. In Airlines, public relations department says that the airline rarely loses passengers' luggage. It further claims that on other occasions when luggage is lost, 91% is recovered. That's their claim right there. Yeah, type 1, null is true. Type 2, null is false, and we fail to reject it. Boom, you got it. Good way to memorize it. I like it. I'm glad these things help out. Every semester I'm trying to come up with new things. We actually came up with some really good stuff in 320. I got to put it in my head, memorize it, so that way I can teach students. Are all the conditions met? Sure, my Pearson. Random 10% success failure. More on those in other videos. So here we see that 67 out of 106. Let's go grab this right here. Okay. Cool. And okay. So Alex, help out with some notation here. You got this. You got this. Let's ace some notation. What do we got notation-wise? Any of the notation. Start the ball rolling on the notation. I'll put some more stuff up here. Nope. Start the ball rolling on some notation right here. That's great. And so what is X and N right here? X is the number of successes, N is the number of trials. So we have to look at the sample size they took and how many successes they were. I can't wait till I can get Taco Bell again. Great job. Great job, Maria. Let's take a look. There we go. Oh no, that's all right. What's correct? Yep, you are correct, Cora. Yep, no. You're free to ask. Don't worry. Those are, I can answer those really quickly, especially while we're doing this. You are correct. The multivariate method is the to look at the impact of multiple variables is the variance inflation factor, because that'll tell us how I'll write the null and alternative while we do this. The null will always have the equal sign. The alternative is the claim we're looking for. We're trying to see if the airline's not meeting their standard of 91% returned luggage. So do we have evidence that less than 91% of luggage is returned to their owner? So let's see if there's evidence for that claim, and it's not looking good for the airline, because here's what we see in a sample. So when we do this problem right here, we need to first find the z-score. And to find the z-score, we're going to take the z-score is equal to p hat minus p naught over p naught q naught over n square root. And p hat, let's go ahead and do p naught q naught over n. There's p naught q naught over n. What is n? 106. I can barely see. There's p naught and we square root. Don't forget to square root. That's a common mistake. I've done it too. Forgotten to square root, and then you get it wrong. Now we're just doing the top part. There's p hat. Just did x over n to get p hat. There's all the decimals. We're going to subtract from it the hypothesized proportion, and we're going to divide by what we saved in our thing right here. So since this is the less than, we were saying to the left side of the curve, bingo. And look at that z-score. That z-score is basically 10. I think it rounds to negative 10. Does negative 10 sound like a very large... Oh, I didn't put all the numbers in here. I'll write the numbers as we... So in case someone's doing this in the future. Does negative 10 sound like a very large number to you? It's all equal to negative 10. Does negative 10 sound like a very large number to you? In terms of z-score. You say negative 10 what? I say z-score. And you say, oh my God. Negative 10 z-score. Are you kidding me? That is ridiculous. Lauren, I want you to figure out, without using the applet, what the p-value for this will be. So go ahead, Lauren, and tell me what the p-value will be. So what is the p-value? And let me make sure that is a way overestimation of it. I want you to round to like 4 decimals. And I want you to figure out what the p-value is for negative 10 z-score. So there's the z equal to negative 10. I want you to guesstimate the p-value for me. Negative 31. Guesstimate your and my p-value. Go ahead and take a guesstimate of your and my p-value. So wait, here's the visual of it. Let's show the visual of it again. There's the p-value. And do it to like 2 or 3 decimal places. Hint, just you can do it to 1 decimal place. Yeah, it's super off the curve. It's ridiculous. It's like we would reject the airline's claim. Like, think about this. The airline is saying, like, here's their claim. And here's what you observe. How far is what you observed from their claim? So when you look at this right here, how far is what you observed from their claim? To determine the VIF cutoff, we use the multiple, and we do just the R squared from the summary. Yep, correct. You take your multivariate R, multiple R squared, saying multivariate, multiple R squared, 1 over 1 minus R squared, and you can see if those are high VIFs. Great job, Kayla, right there. And they should be pretty ridiculous. They'll be pretty ridiculous. You might see like a high cutoff is like 4. Maybe I'm trying to think what the R squared is. It's 10 standard deviations away. Yep, which is ridiculous. That's super crazy away. So, like, do you think that their claim is likely, or you reject their claim with what you observe? With what you observed right here in your sample, because this is what you observed. You observed something right here, and this is their claim. Like, you're going to do what to their claim right here? You're going to be like, I saw in my sample 63%. You claim 91%. Correct. Don't square the R squared. Yep. 1 over 1 minus R squared. Don't square the R squared. Yep. Yeah, I did. That claim is junk. Yeah, no, Lauren, let's throw some 50 points. The Lauren, you're getting the hang of it right here, because you're going to be like, I don't just reject that claim. I throw that claim out. That's ridiculous. And great job, Kayla. Thank you. This goes out to Lauren and Kara right there. So null is, oh yeah, we're rejecting that null. We're like, this is a ridiculous claim. Like, if I were to like do the statistics on this, I'd be like, the claim the airline is making is ridiculous. We have such strong evidence that it's wrong. I reject their null. It's quite obvious to me that the airline is not meeting their standard. So, like, that's why I wish these could be, like, written problems, because I'd be like, that claim from that airline is absurd. My Pearson going, come on. So, what? What are you doing, my Pearson? You good? You good? So we get here the z-score. I think it was with 2 decimal places. It was rounded to -10. Let's double check our rounding. Yeah, that would round up. Everything rounds up. -10. Hopefully we carried all our decimals. P-value going to be 0. In case you don't believe me, you could go here and you go below and go below -10. It's 0. It's not even showing it to you. So my Pearson is quite sus today. And then do these results cast doubt on the airline's claim? Yes, since the null hypothesis is rejected, and my Pearson's even got a repeat answer. Wait, do we have one more? What did I not enter? Oh, I didn't answer the alternative. We're trying to find evidence of less than. My Pearson, you better not be mean to me. So that's just so weird right here. What was I going to do? I was going to do something else this question. But that's got it. That shows that my Pearson, the claim is sus right here. That claim does not seem likely by random chance. Like, we would reject the null, definitely. Oh, I was going to find the exact p-value. If you really want to know what the p-value is, you can go here to pt, and I think this should do it. Oh, no, p-norm. That's correct. Okay. So we're at a p-value of that. That's the p-value. Oh, no, the z-score is crazy. The z-score is ridiculously large. And then what was your... So I can find... Maria, if you have your z-score... So weird when I change colors on the screen. I know, it's ridiculous tiny. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 7, 6, 1, 9, 8, 5, 3. So there's the p-value right here. Your p-value would be... There's your p-value. Yeah, so there's your p-value right there, Lauren, which, if you notice, the applets are not really set up to return numbers like this. So I'm at 23. So yours should be about something like this right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, one too many zeros. We don't want to estimate it incorrectly. That is your probability of your results, Lauren, right there. Does that make sense? Yeah, I think that was or Alex's. But basically, it's just impossible. It's basically impossible for the airline's claim to be true. Like, you have a better probability of winning the lottery than this airline does of this occurring. So you could say, well, people win the lottery. Maybe this was just a bad day for the airlines. Maybe the airline's claim is still true. It's just that they had really bad luck with what they got with the random sample. It's like, yeah, but I mean, people don't win the lottery that often. Probability of winning the Powerball. No, let's say the next question here is something like... It's something like that, which this is like winning the Powerball almost not quite twice in a row. It's like, I don't know. It's comparable. Would it be like winning the Powerball twice in a row? If that's Powerball probability. Yeah, it's like winning the Powerball twice in a row. It's like you win the Powerball and then you win the Powerball again. That's what we're talking about, what we saw for this airline luggage. Like, the airline's like, it was random. And you're like, I don't think this occurred randomly. I think it's true that their claim, it's based. I'd say, if I'm talking to someone statistically, Alex, I'd probably say it's basically 0. P-values can't be 0 because you can always observe something by random chance. Like, you can estimate p-values to be 0, but p-values can never technically be 0 because something that occurs can occur, and anything that can occur by random chance. So a p-value can only approach 0. A p-value can never be 0. But in some purposes, we might just say that the p-value is close to 0. Like, does that make sense? We might say that the p-value is basically 0. Like, in this point, I'd just say it's basically impossible. Like, what if someone said, imagine, Alex, if I said to you, what's the probability of winning the lottery 5 days in a row? Yeah, so it should be 0. It says round to 4 decimals, it's going to be 0. They use those interchangeably. When it's independent, it's random. How do you know when to use P or mu? Great question right there. Here, we'll do that. Let's cut the video. If someone said to you, and here, I'll go to Cody's question next. Oh, wait, I missed chorus for a moment. So if we get a VIF cutoff of 1.25 and our VIFs for our variable is 1.23, it's not that it's not significant. It's just that there's not multi-collinearity issues. So Cord, did you catch that one? If your VIF cutoff is 1.25 and you get a VIF of 1.23, you would say that variable does not have high multicollinearity. Like it doesn't have overlap with your x's. Does that make sense? VIFs tell you the amount of multicollinearity. And so what you would say there is we do not have a high degree of multicollinearity that between the x's explaining each other. So whatever variable that is does not have a high degree of multicollinearity with the other x's. So if the VIF of your variable is below the VIF cutoff, there's not an issue of multicollinearity with that variable. When the VIF is above the VIF cutoff, we would say, and so does that make sense here? I'll show a model right here real quick. And then Cody, we got your next question next. Thank you everyone so much. My z-score is, and that looks about right. Yep. So your p-value is 0.49, Maria. Is your p-value high or low? So VIFs, we don't really talk about significance. So here we'll talk about VIFs for a moment here, and then we'll do Cody's and then Maria's question. Maria, that looks like a very high p-value. When the p-value is high, we let the null fly. Just let the null fly. So I think I have a model saved right now. And I'm looking at very similar things. So to find the high VIF cutoff, we do 1 over 1 minus r squared. And I'm getting the same results everyone else is getting because it's the same model. I didn't do random samples. We don't talk about VIFs. You're welcome, Maria. We don't talk about VIFs as being significant. We talk about VIFs as being too high. And what it means that a VIF is too high is that the information brought by these variables would be what with the other variables in the model. Like by having high VIFs, it means there's confusion. And so the information brought by these variables is what with the other x variables in the model. And it's probably because we're creating an interaction from variables. So the high VIF above the cutoff means that the information brought by chlorids is what with the other variables in the model, by it being above this cutoff right here that we calculated. So by it being above the cutoff, it means that it's what? High VIFs, which look for multicollinearity, means that kind of dependent, it would mean it's redundant. So it's going to mean that it's redundant information, and then the model gets confused. When there's redundant, great job, Kayla, right there. When there's redundant information, the model's like, well, what do I do with this? And so it does what to the variance? What will it do to the variance? What will it do to the variance of the estimates of the coefficients? What will it do to the variance of the estimates of the coefficients? What will it do to the variance of the estimates of the coefficients? I've got a hint on the screen. It'll what them? What will it do to the... You're welcome, Noble, anytime. So glad. I'm glad these help out. We always try to cover as many topics as we can. Stay over a little bit sometimes. I started a little bit late today, I know. It's going to increase, inflate. Exactly. It's going to inflate it. It's going to increase it. And this is a bad thing because variance directly relates to the what of the model. Variance is what squared. We don't want it to inflate the variance. Variance relates to the standard error because how could we find out an estimate of how much the standard error has been inflated? Remember, standard error, we can get standard error inflation if we just do what to variance. This is like a super in-depth talk about this because we haven't talked about it in a while. Like you don't need to go this much in detail, but so yep, it relates to standard error, and we can just take and we can square root variance, which is the idea of, standard deviation squared is variance, so we can square root this and get the standard error inflation, and 25 square root is about 5. So we get that this has been increased about 5 times. So if I were to make a model here with just, let's say, chlorids. So if I were to make a model with just chlorids, I'm guessing it's going to be a different model. But a model with just chlorids might have an uncertainty of about that. We'll find out. We'll find out the hard way. Good. Did I make a mistake? What did I make a mistake on? Y tilde x comma data equals... Oh, I'm doing quality. We're not doing quality right now. We're doing alcohol. Sorry. Wrong brain. There we go. And oh my gosh, look at this. Do you remember what I found earlier right here? Talk about amazing. Now, it doesn't always turn out perfectly like this, but I mean, that's ridiculous. Got to pull out that Joker impression again at some point. Maybe, you know what we could do last class or something. Maybe we'll do that for the last class. Maybe if I'll look to see how much makeup I have. Maybe I should do that for the last class this semester, like be the Joker. Maybe that'd be fun. I think it'd be fun. It's a good it's a fun day to be the Joker. But then I have to do it for like 2 classes is the problem. And yeah, you can see that the variance has been inflated by about a factor of 5. Now, this is a different model, so you're going to get different estimates. So sometimes this example has not worked out for me. I'll thank you so much, Noble. Like, it might be, like, I might just do it on one day. Or I might do it 2. I don't know. It's a lot. It's a good, like, 30 minutes to an hour of getting ready in the morning. Well, I don't have to do the hair. I just have to do the makeup. I think I have enough makeup. I'll have to ask Chelsea if she has enough black eyeshadow. Oh, I can just order it. Because we got enough time for the end of the semester. So maybe I'll order more black eyeshadow. Like I get like let me look. I should order more Joker supplies. Great idea there, Noble. So we should do like last class Joker. That'll be fun. It's last day is meant to be fun. Last day is meant to be enjoyable. I'll be doing like the business analytics lecture as the Joker. Can you send me my interpretations on Discord? Yep. Mm-hmm. I'll look over that. And I think Cody had questions. How do you know when to use P or mu? We'll head over here. We'll do this. How do you know when to use P or mu? Finishing up office hours here. Thank you, everyone, for all the positivity. I really appreciate it. Background breaks and all this stuff. Eventually, I'll start using OBS and not Streamlabs OBS. Eventually. So let's ask a question right here. Brian wants to collect data on how many trips to cook out students at UT take a semester. He takes a sample of 200 students, and from his sample, the average was 12 with a standard. Identify parts of the problem. Awesome. Enjoy Kingsport. Yes, Kingsport group right there. Go grab some. As long as you're eating. If you are eating out, I'm not. But get some pals. If you are in the I am okay with eating out group. Everyone makes their own personal choices right now, and I'm like one of those crazy people. Not crazy, but I don't eat out. I miss it. I miss my Taco Bell. One of these days. Taco Bell's trying to put out some nacho fries commercials, trying to tempt me with those nacho fries. How dare you, Taco Bell? You know I love nacho fries. So what do we see right here, and how do we know if this is P or mu? So how do we know if this is P or mu? How would we know if this is P or mu? How would we know if this is P or mu? Any ideas? P or mu? It's a big important thing. Awesome. Anytime, yeah, Noble, that'd be awesome. It's like I miss swinging by campus. Hopefully next semester. If I'm flying in once a month, that'd be awesome. Mu because average. Great job, Lauren, right there. Yes. We are looking at the average right here. So the null hypothesis is that the true mean of times that students go to cookout is 10, and the alternative is that the true mean of times that students go to cookout is more than. I was looking for evidence of more than. I was like, what is that? There we go. Great job, Lauren. Yep, that's the practice. That's the good practice right there. We're trying to see if there's evidence of more than 10. So that means we've identified additional notation. That is the sample standard deviation. That's the sample size. This is the sample average. This is the hypothesized. And let's go ahead and do part 2. Go ahead and do part 2 right here. So now we want t with n minus 1 degrees of freedom. Degrees of freedom is 199 because it's n minus 1 is equal to y bar minus mu naught over s over square root of n. And thus we get the following. Let's go ahead and plug in the numbers here. We get 12 minus 10, which is 2. And then we take 8. We divide by the square root of 200. So the t statistic right here is going to be 200, 8 divided by, and then that's, copy that, 2 divided by 3.5. We're going to get a very small p-value. So basically, when we do this right now, now that we have the t statistic, we can go down here and we can draw it. This is a t with 199 degrees of freedom, and we do it just like the p-value, the z-score. And you can't see it, it's beyond me right there. And, oh, good to see you here, JG. Ah, really? There, man. I want it to be close enough to the... Oh, dang it. I think it's like I'm drawing it like slanted. Sure. That's where the t is at of this. And then the p-value is this. The p-value here is going to be very, very what, Lauren? So the p-value right here for this problem, if we should go to the t-applet though. We can show it. We can show the p-value right here for this problem. But this would be evidence. This is going to be strong enough evidence at the 0.05 alpha level. I didn't even do it enough justice because you're not even really going to be able to see it. It's going to be off the curve when you talk about where we're at. It's going to be super small. So yeah, it's going to be a super small t, which is going to be strong enough evidence. We're going to the t with 199 degrees of freedom. Lauren, great job. Is that it right there? Oh, that's such an amazing guess right there. It's probably going to be closer to. That's a really good guess. Here, I'll give a guess too. Before I enter this in, let me give a guess. No, it's a good guess. It's small. And we can do this more exactly. The t-applet's probably gonna say point. I'm trying to think. I'm slowing down my mind here a second. T-applet's probably gonna say this. It can only go to that many decimals. It might even say 0. It's gonna say that. There's my guess. That's my guess right there. So let's go ahead and take this t. And we're looking for evidence greater than. And it says 0. So we have to use technology like this to get it. And we want to go to qt. We have to put in the value. Wait, I put in the wrong amounts. Is it PT? I always get it wrong. There we go. And that's the exact number. So there is, and that's why it's rounding it to 0. So it's rounding it to 0 right there. That is the exact number. Does that make sense? So, it's close-ish. It's very small. Good enough guess. It's super small. It's ridiculous. Like, it's very, very tiny. It's a non-existent p-value. So you definitely reject the null. But yeah, it's very hard to guesstimate, especially when it's that small. You could just say it's very small. It's basically 0. Yeah. So, and that's why the applet over here is saying 0. And you would have to use like technology like this to get a more exact estimate on it. But the applet's like, hey, your p-value is small. It's off the curve. You can't even see it. It's over here. And if you look at our drawing for this, our drawing also confirms like what's the difference between t and z and find it. So Mr. T is what? Mr. T is what? Whenever we're doing t's, we're always doing tests for the what. So the t and the z will be used to find the p-value. Yep. So I think, so the t and the z are both used to find the p-value. The t and the z are the standardized metric. Does that make sense? The t is used on the t curve. The z is used on the normal curve. So that's great job. Does that make sense, Lauren? And this is t because it's averages because it's mu. Mr. T is means. So if you're doing drugs, I think that's got it. Excellent work, everybody. Excellent work. Let's go here to space. A little music and office hours. Excellent work. You're welcome. Great job. Whew. A lot of work today. Keep up the great work, everybody. Semester's almost over. We just got like, what, week and a half left? 2 weeks? With that, you got this. We will be back. I'll see everybody soon. Bye for now. Bye.